Hi everyone, welcome again to my YouTube channel, and today we'll be solving a problem from Project Euler, which is the even Fibonacci number problem. So we'll be using dev C++ as our editor, and okay, let's start. So the problem says each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so forth. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even value terms. Okay, so we have a problem here which says that the sequence, the Fibonacci sequence, is formed by adding the previous two terms. Okay, if you start with 1 and 2, so if you add 1 and 2, you get 3. If you add 2 and 3, you get the next number in the Fibonacci sequence, which is 5. If you add 3 and 5, you get the next number in the Fibonacci sequence, which is 8. Okay, so this is how the pattern is. But at the end, the problem wants us to return the sum of the even value terms. So terms that when divisible by 2, the remainder is 0. Okay, so let's look at this problem. Let us think of what are the requirements. So the input, what is the input? Requirements, and the output requirements. Okay, if you look at the input requirements, we know that the input is a Fibonacci sequence, Fibonacci sequence, which is formed by adding the previous two terms. But if we look at this sequence that we're given, we already have 1, 2, 3, 5. Okay, but how can we get 1? So we're gonna have to find ways of getting 1. But again, the problem wants us to return the sum of the even valued terms. So even value terms, meaning that terms that when divided by 2 return a remainder value of 0. So terms that when divided by 2 you now have a remainder. Okay, now these terms are like 2, because if you take 2 divided by 2, you get 4. 4 divided by 2, it's 2, so they don't have a remainder. So now if we look at the sequence here, okay, our even valued terms that we have is 2, 8, 34, okay, and so forth. Now, looking at these terms that we just written, that we have just highlighted before, so 2, 8, 34, these are even valued terms. Now, if we were to find the sum of even valued terms, let's say within the range of 55, okay, we would have taken these three terms, add them together, okay, we would have added these three terms together, okay, and our return value should be 44, because 8 plus 2 is 10, then plus 34 will give us 44. So that should be our return value. But again, the question also says that we have to consider the terms in the sequence. So we have to consider the terms. So consider the terms in the Fibonacci sequence that whose values do not exceed 4 million. Okay, now that means this sequence, the values in the sequence, they should not go over 4 million. Okay, that is something that we need to think about as well while we are designing that function. So we already know that our input is a sequence formed by adding the previous two numbers, okay, and the values in the sequence should not exceed 4 million, okay, and we need to return the sum of even value terms which are present in that sequence. Okay, so on that note, we can start by defining a function, okay, that takes in the maximum limit or maximum value in the sequence, that this maximum value is the maximum value that the terms in the sequence should not exceed. Okay, now we then say that the first number, we know that if we look at the sequence, the first number is 1. Okay, how can we get 1? We can say that we can do it this way, that let's assume, because we know that the numbers or the terms in the sequence are formed by adding the previous two terms. Okay, we know that, so we can say that the first number can be considered as the sum of its previous two numbers. Okay, so what are its previous two numbers? What are the previous two numbers of the term 1 in the sequence, of the value 1 in the sequence. We can say that let the first number to be 0, okay, and let the second number to be 1. Now the sequence can be formed by adding the first number and the second number. Okay, now the sequence value that we'll get here will be 1, so we will have 1. But how can we get 2 after this? If we look at this, we can say that we know that the limit is 4 million. Okay, that's our maximum value, like we discussed before. In that case, we can put it in a loop, in a while loop, because the sequence keeps on adding up. It will keep on adding up until the point it reaches that it doesn't exceed the maximum value that we are given, which is the 4 million. So we can say while, sorry, put it here. Okay, we can say that while the sequence, okay, the sequence value is less than the maximum value. Okay, while the sequence value is less than the maximum value, we can say that the sequence value will be equal to the first number plus the second number, like we just found over here, like we just talked about it right here. And now the first number will be updated to have the value of the second number, and the second number will then be updated to have the value of the sequence value, the current sequence value, and then it will start again. So what's happening is, initially we know that the first number is 0 and the second number is 1, so our sequence value will update itself by having a value of 1, and then the first number, instead of being 0, will be 1 this time, and the second number will be the sequence value, which is 1, which has been updated to 1 before reaching this point. Now if we go back here, the sequence value will be the first number, which is 1 now, it's not 0 anymore, and the second number, which is 1 as well, because the sequence value before was 1. Now the sequence value will be updated to 2. Okay, so we'll have sequence value of 1, 2. Now the first number is updated to 1, the second number is updated to 1 as well, but in this case the first number will be equal to the second number, which is 1. Okay, and the second number will be updated to the sequence value, which is 2, as we obtained before. And if we go back to add the same first number and second number to update our sequence value, we will obtain the value of 3, and so on. Okay, now in this case we have to find the sum of even value terms. Okay, now in this while loop that we are designing here, what's going to happen is we will have the sequence values or terms in the Fibonacci sequence. Okay, so we will have the terms that we are looking for in the Fibonacci sequence. Okay, then we can store these values in an array. Okay, so we can have a vector array, and we can call this vector array Fibonacci sequence array. Okay, we can call this Fibonacci sequence array that will be taking in the sequence value, the values of the Fibonacci sequence that are being produced over here. Okay, so say Fibonacci sequence array, pushback will be pushing back, so we will be storing this sequence values in that array. And we will, once the loop is done, okay, so once we have reached the condition that is going to exceed the maximum value, we will then have the terms of the Fibonacci sequence inside the Fibonacci sequence array that we just defined over here. Okay, so in this case now what we will do is we will iterate through the Fibonacci sequence array, and what we will do is we will find all elements that are evenly divisible by 2, meaning that they don't bring any remainder out of it, and we will add all of them and store the sum in a variable called sum of even. Okay, and then we will return the sum even variable. Okay, all right, so let's do it now. Let's implement what we just did design over here. Okay. So we'll first start by including libraries that we need to solve this problem. Now looking at our design, our solution design, we can see that we are using vector arrays, and that case we will need to include the vector library. Okay, and then let's start by creating that function because it will be returning an integer. So let's start by creating that function, and let's call it sum of even valued terms in the Fibonacci sequence. That will take in, like we said before, that will take in the maximum value, okay, which is the 4 million. Okay, maximum value can be any, but in our problem we are supposed to consider 4 million. Okay, now initially as we designed, we will create these three variables: first number, second number, and the sequence value. Okay, so we can say that sequence value equals to 0. First number, all these will be integers, is 0. Then second number will be 1 for our case. Okay, and then we will say that while the sequence value, okay, while the sequence value is less than the maximum value, we will say that the sequence value will be equals to the first number plus the second number. Okay, and we will update the first number to be the second number. Okay, and we will update the second number to have the value that was obtained from the sequence value. Okay, have the sequence value. But in our case as well, we are looking to store the sequence values in an array. So in our case, we will define a vector array that takes in an integer. We will call it Fibonacci sequence array. Okay, now this Fibonacci sequence array, we'll use it to store the sequence values. Okay, Fibonacci sequence array, we'll use it to store the sequence value. Okay, then at the end, while this condition has been fulfilled, we will then go through the array from the first element till the will iterate through the array from the first element till the last element. Okay, till the last element, and then we will see if that element, okay, so if there is an element in the Fibonacci sequence array, okay, that when divisible by 2, okay, gives a remainder of 0, we will then first we want to create a variable called sum even that will be adding the even value terms. Okay, so we will add those terms that give a remainder of 0 or are evenly divisible by 2, or yes, or are evenly divisible by 2. So the some even variables will be adding, sorry, I forgot, we'll add these terms that are divisible by 2 that are found in the Fibonacci sequence array. So Fibonacci sequence array, okay, and then once this loop is over, we'll then return the final result, or the sum of those evenly valued terms. Okay, now let's create the main function. Okay, and let's print out the results obtained from this function. Okay, we can start by just having an input of 55, because if you have an input of 55, then we're expecting the value to be 44, like we talked about here. If we start with an input of 55, we're expecting a value of 44. Now let us see if that's what we get. Okay, Fibonacci, so include vector, having a bit of a problem. So if we include vector, okay, you have vector integer. Let's call it Fibonacci sequence array. In that case, we just have this one. Okay. Okay, so this should work. Let's see what the error is. it says wasn't declared in the scope. Okay. Okay. Because we are not printing anything. So, okay, found the problem. Because we are printing here, we need to include the library for printing, which is the stream, and this should be okay now. So okay, has to be the size of the Fibonacci array, and yep, it should be okay now. So the value we get is 44, as you see here. Now in our case, now we need to test for the 4 million. Okay, so 2, 3, 4, 5, 6. Okay, let's see what do we get. Okay, so this is the value that we get. We get 4613732. All right, so let's put it in here. Let's put it in here. 4646732. Okay, let's check to see if that's the correct. Yes, and that's the correct answer. A bit challenging, but we got through it. Yep, thank you all for watching my video, and I welcome anyone who's got a better solution. We can reach out so we can see how we can help each other to come up with much better efficient solution. All right, thank you so much. See you in the next one.